16代目のクラウン、日本の歴史に重ね合わせれば、それは明治維新です。ご覧ください。新しい時代の幕開けです。
Toyota, the world's largest car maker, faces challenges from the growing electric vehicle market and new competitors. To address this, Toyota has introduced a revolutionary new engine to transform the car industry and regain market leadership. What makes this engine unique? How will it change the car industry? Join us in this special episode as we reveal Toyota's new engine that aims to surpass the electric vehicle market. EV Devastation. Toyota had its best year ever in 2023, selling a record-breaking 11.2 million vehicles. However, electric cars contributed little to this success. Only around 104,000 were electric, just about 0.926% of all Toyota and Lexus cars sold last year. The company believes there is still a strong demand for traditional engines. The chairman thinks people should have a choice and not feel pressured into buying electric cars. He emphasized this during a speech to 200 corporate managers and executives, where he mentioned plans for a significant engine project that he had previously discussed at the 2024 Tokyo Auto Salon in a Q&A session. Toyota believes that despite technological advances, electric cars will be at most 30% of the market, with the rest being traditional engines, hybrid cars, and fuel cell electric vehicles. He also sees hydrogen-powered engines as a future solution but should have mentioned diesel. He announced that Toyota is ready to reveal a new combustion engine project in 2024. Ford is a pioneer company among car makers planning to switch to new electric vehicles, some of which intend to phase out traditional engines in the coming years. The strategies name specifically automakers such as Jaguar, Chrysler, Lotus, Aston Martin, Bentley, Buick, Cadillac, Rolls-Royce, Genesis, Maserati, Mini, Opel, Vauxhall, and Volvo to launch only electric vehicles by 2030. Some of these were that even Toyota's Lexus division declared that it would cease producing cars dependent on combustion engines for power in Europe by 2035. Stellantis has set an aspiration to sell only EVs, and Mercedes already said that it wants to become fully electric in the old world by 2030, provided that its market conditions will allow it. Audi, one of their chief rivals, has recently said they will no longer deliver new combustion engine 2032. When BMW plans to implement such technical systems, the company has not announced a date. The Volkswagen core brand wants all its European cars to be electric by 2033. In general, it is possible to notice that Toyota has a somewhat different approach to these issues. They also think battery electric vehicles can be one of many possible solutions to carbon neutrality. If you were surprised by the idea that battery electric vehicles can be one of many possible solutions to carbon neutrality, get ready for something even more surprising: how it will destroy the entire EV industry. AKO Toyota insisted that the time has come to fill the gaps with properly functioning charging stations. He illustrated how, in parts of the world where approximately 1 billion people have no access to power, for instance, Toyota sells cars, so going fully electric would not be ideal. That is why they invest money into developing an engine that utilizes hydrogen. In recent decades, Toyota has distinguished itself as a critical tech pioneer, and a new internal combustion engine will be outstanding. How do hydrogen power engines work? The fundamental efficiency of this technology lies in using water as a fuel. But how does one extract energy from water, a seemingly impossible substance? The answer lies in the molecular makeup of water, scientifically abbreviated with H2O, which is composed of hydrogen atoms consisting of 2 hydrogen atoms joined to 1 oxygen atom. Through the process of electrolysis, the 2 constituent atoms of the water molecule, hydrogen and oxygen, are separated so that the stored energy in water can be harnessed. It is a way to conduct electricity through water to convert water into hydrogen and oxygen gas. One of the advantages of hydrogen is that it has high energy density and can be used to produce energy. Comparatively, hydrogen generates much energy when burned, on par with the standard gasoline-powered engines. Nevertheless, while bus-using gasoline production generates toxic fumes, hydrogen combustion produces only water evaporators. It is, however, evident that they have high potential, as shown above, but there is room for additional improvement to enhance the practicality of these engines. If you found the inquiry into how hydrogen power engines function surprising, get ready for an even more astonishing unveiling. What sets this new engine apart? For instance, there is a need to enhance systems for splitting water efficiently, devise safe methods for hydrogen storage, and create engines that can effectively utilize hydrogen. The goal is to eliminate the need for complex electric or hydrogen systems. This simplicity benefits electric car users who often struggle to find charging stations and makes refueling easier than hydrogen. Experts are curious and ask questions like, can hydrogen-powered performance match that of traditional gasoline engines? Will the driving experience be enjoyable? What makes this new engine stand out? Hydrogen-powered engines can match the performance of their gasoline counterparts thanks to hydrogen's unique nature as a fuel. When hydrogen burns, it does so much faster than gasoline, resulting in rapid combustion that enhances engine responsiveness, which is critical for driving performance. In a traditional internal combustion engine, drivers expect immediate throttle response, a distinctive engine sound, and a sense of power. Toyota's hydrogen-powered vehicles can replicate these characteristics using a cleaner fuel source. Drivers of Toyota's hydrogen-powered cars can still enjoy the familiar sensations of driving a conventional vehicle, including the engine sound, which is a crucial part of the driving experience for many. These vehicles also excel in racing scenarios, as demonstrated by Toyota's rigorous testing of hydrogen-powered models, showcasing their reliability and potential for high-performance applications. Hydrogen engines can compete with traditional racing cars in speed, agility, and endurance, delivering comparable horsepower to gasoline engines. Toyota's foray into this technology has yielded promising results by modifying and refining existing engine designs to accommodate hydrogen fuel. Toyota has achieved power outputs that rival or exceed conventional gasoline engines. This achievement represents a technical breakthrough and underscores hydrogen's potential as a proven alternative for high-performance vehicles. Toyota has successfully merged the dynamics of traditional internal combustion engine vehicles with a clean and sustainable fuel source. This approach by Toyota is bridging the gap between present-day automotive technology and the future, offering vehicles that retain the performance characteristics of conventional ICE vehicles, whether on the racetrack or for daily commuting. Toyota ensures that the performance sensation and enjoyment drivers expect from traditional cars are delivered while leading us into a new era of environmental responsibility. In developing these new engines, Toyota considered hydrogen's numerous fascinating environmental benefits. What could these benefits be, and what is the potential impact on the environment? Toyota's utilization of eco-technologies is unique, stimulating the debate about future hydrogen-fueled internal combustion engines. Concerning the comparative footprint of these engines with hybrid electric vehicles and plug-in hybrid electric vehicles, as well as the defining characteristics of hydrogen engines, the more recent descriptions of the environmental advantages of hydrogen engines shed some light. However, what is unique is the emission profile, which deviates markedly from what is typical of a gasoline engine. For instance, fully built gasoline engines emit considerable concentrations of carbon dioxide, which causes the greenhouse effect. Hydrogen engines are still present in Toyota vehicles, and unlike gasoline engines, they emit zero CO2 during their operation. The primary emissions from such engines are water vapor and, as such, are very environmentally friendly when analyzed using the emitting of greenhouse gases. This is accomplished by employing the hydrogen engine combustion method, which has negligible environmental impact. Hydrogen fuel can be used directly in engines, where it combusts oxygen into the air to obtain energy. Water is the only emission from this process. This clean process is offset sharply by burning fossil fuels that comprise carbon in the fuel hooked up with oxygen to form CO2. Exempting CO2 emissions from automobile tailpipes can be viewed as a significant advancement in addressing the effects of the automotive industry on the climate. Hybrid electric vehicles, which are also referred to as HEV, are motor vehicles that use both a gasoline engine as well as an electric motor. Another subcategory of HEVs are the plug-in hybrid electric vehicles known as PHEVs, which are mobiles that can plug into external electrical source to recharge the battery. However, they continue to need gasoline, hence they release CO2 in use, although this is in lower quantities than ordinary cars. On the other hand, hydrogen engines give accurate versions of banned emissions if the hydrogen used in the engine has been produced environmentally. There is also the issue of life cycle emissions of these vehicles and the improvements in greenhouse gas emissions. HEVs and PHEVs have batteries made of rare earth metals and whose manufacturing processes are detrimental to the environment. Hydrogen engines, on the other hand, do not present such challenges. Primarily, hydrogen fuel is generated using renewable energy in the form of wind or solar energy. Thus, the overall life cycle of hydrogen fuel is environmentally friendly compared to battery production. Like in any regular internal combustion engine, the efficiency of a hydrogen combustion engine can be equally efficient, or even a little better depending on some conditions. This is especially true in applications where maximum torque and power are critical, such as in hydrogen engines that can match the electrical output of fuel cells. Fuel cells power at peak, producing considerable power at low loads, and do not perform well at high loads, while hydrogen combustion engines produce high loads at high loads. This makes hydrogen combustion engines more appropriate, especially in applications where superior performance is desired. Technologies like Toyota's hydrogen engine are precious now, as the world grapples with the challenges of climate change and dwindling resources. They offer new hope for cleaner and greener transportation without sacrificing performance or practicality. Toyota is also setting a new standard with its approach to carbon neutrality, aiming to eliminate carbon footprints. How can they accomplish this ambitious goal? How the combustion engine will destroy the entire EV industry. We have been talking about the combustion engine occasionally, saying how good it is and how it will destroy the entire EV industry. But how different is it from the traditional internal combustion engine? What are the technical aspects of this engine make it stand out even more? To answer these questions, we will focus on one of Toyota's standout achievements in this field, the 1.6-liter, 3-cylinder turbo engine. For those of you wondering why we are looking at this specific one, it is because it is one of Toyota's most successful hydrogen engines. It is currently being used in the Corolla Cross hydrogen prototype and performing wonders. This engine perfectly blends traditional design with pioneering technology and is good at it. However, it is entirely different from a conventional internal combustion engine. You see, the 1.6-liter 3-cylinder turbo engine is just marvelous in the engineering world. Toyota based this engine on the same platform as the engine found in the GR Yaris. And as we all know, the GR Yaris is known for its performance and agility. However, for the engine to support hydrogen, Toyota had to make several modifications. After these modifications, a lot of people had a lot of questions about it. However, everyone asked one question: how did Toyota maintain its engine performance while switching to a different fuel source? The secret lies in the hydrogen combustion process. Compared to gasoline, hydrogen requires completely different handling and combustion techniques. With that in mind, the engine uses a high-pressure hydrogen direct injection system. This is a significant departure from traditional fuel injection systems. The engine can control hydrogen delivery into the combustion chamber with this system. This dramatically optimizes performance and efficiency. But even with this, how is the engine's overall performance impacted? You would be surprised at how this hydrogen engine performs. The 1.6-liter engine can produce enough power and torque to compete with its gasoline counterparts. This is primarily thanks to the turbocharger, which plays a massive role in ensuring that the engine delivers the necessary boost to make it high performance. However, there have been concerns about whether turbocharging is the way to handle the unique properties of hydrogen. The main reason for this concern is that, compared to gasoline, hydrogen has a relatively lower density. Because of this, the engine would require a larger volume of hydrogen to achieve the same energy output as gasoline would. Toyota's engineers have noticed this and are taking the challenge head-on. They have ensured that the turbocharger and other parts of the engine are properly optimized to handle the unique properties of hydrogen fuel. One of the things that makes this engine even better is its efficiency. It turns out that the efficiency of hydrogen combustion engines is way higher than traditional engines. This effect is felt more during high-load situations. As a result, it dramatically affects the fuel economy and has an environmental impact. The increase in efficiency means that the engine has a better fuel economy. Most importantly, it means that there is a significant reduction in emissions. After all, the only byproduct of the entire combustion process is water vapor. This technically means that it has near zero emissions. As we saw earlier, this makes it one of the most environmentally friendly options. It is essential for Toyota to achieve near zero emissions from the hydrogen engine because it aligns with its carbon neutrality campaign. If you were caught off guard by the concept of how it could dismantle the entire EV industry, get ready for an even more astonishing insight. Toyota's new fuel cells, poised to extend the utility of fuel cells beyond just automobiles. As Toyota moves towards a future of carbon neutrality, the automaker has employed more than one strategy to achieve this. Instead of a one-dimensional approach, the automaker has opted for a diverse application of hydrogen and electric technologies. Given their technology, the automaker could achieve this with a one-dimensional approach. But why go for a multifaceted approach in its quest for carbon neutrality? Let's start with Toyota's commitment to hydrogen technology to understand this. Hydrogen technology. You might be wondering, why go for hydrogen? The answer lies in its potential as a clean energy source. When hydrogen is used in fuel cells or internal combustion engines, it only produces water vapor. This means that it is the most environmentally friendly alternative to fossil fuels. However, Toyota's investment in hydrogen technology is for more than just passenger vehicles. Toyota has used this technology in commercial vehicles and even public transportation solutions. But is hydrogen technology alone enough to achieve carbon neutrality? Let's just say that Toyota has looked into this because, by recognizing the limitation of using a single technology, Toyota has also embraced electric vehicle technology. One of the main components of Toyota's strategy to achieve this is the development of battery electric vehicles. However, they have used a somewhat different approach than other automotive manufacturers, especially those focusing entirely on EVs. Toyota's diversified strategy considers some challenges to the widespread adoption of EVs. The most common challenges include the limited range, long charging times, and the environmental impact of battery production and disposal. To deal with this, Toyota has offered various powertrain options, the most common being hydrogen fuel cell vehicles, plug-in hybrid electric vehicles, and BEVs. With these powertrains, Toyota aims to cater to a broader spectrum of customer needs and driving conditions. This whole diversified approach leads to the broader goal of carbon neutrality. However, Toyota has managed this in various ways. One of the things they have done to understand this is to realize that different regions and markets use different energy sources, infrastructure, and environmental policies. A one-size-fits-all approach may not be as practical as expected in reducing global carbon emissions. For example, consider regions where they use reusable energy. For such a place, BEVs would be the most suitable option. On the other hand, in areas where hydrogen production is powered by renewable sources, FCEVs and HYCEs could be a better option. If you were amazed by the idea of using hydrogen technology, get ready for something even more surprising. Hybrid synergy drive, which is shaping the future of driving. However, Toyota's dedication to carbon neutrality extends beyond reducing vehicle emissions. The company actively participates in initiatives to lower its manufacturing processes' carbon footprint. They are now advocating for recycling and resource efficiency while investing in renewable energy projects to accomplish this. Nevertheless, there's still more to be done to achieve the ambitious goal of carbon neutrality. Understanding the impact of Toyota's strategy requires looking at the bigger picture and being aware of the numerous changes needed to achieve a nearly carbon-neutral society. This applies not only to vehicle technology, but also to energy production. Toyota's multi-technology approach and its sustainability initiatives in other areas demonstrate a comprehensive effort to tackle these challenges. Limitations that the hydrogen engine industry faces. One major hurdle is the need for more infrastructure to support hydrogen fueling, which currently needs to catch up to the well-established gasoline and electric vehicle charging networks. Hydrogen requires specialized storage and distribution systems due to its high flammability and low density. Creating a widespread and accessible hydrogen refueling network requires substantial investment and coordination. Safety is another serious concern due to hydrogen's high flammability, making it a potentially risky fuel. Toyota is addressing these concerns through meticulous engineering and strict safety protocols. They're developing large container systems for storing hydrogen fuel and advanced sensor technology to detect leaks or prevent accidents. Ensuring public safety goes beyond establishing rules. It also involves educating people on safe handling practices. This is particularly crucial with hydrogen, which can pose risks if mishandled. Everyone must understand how to safely store, transport, and use hydrogen to minimize accidents and mitigate risks. However, educating everyone about hydrogen safety presents significant challenges. It requires considerable time and resources to develop comprehensive training programs that cover all aspects of hydrogen safety and ensure widespread dissemination of this information. Despite these challenges, if we can overcome the hurdles associated with educating the public about hydrogen safety and ensure widespread awareness of the risks involved, we can fully unleash the potential of this technology while prioritizing public safety. Achieving this will require collaboration among governments, businesses, and educational institutions. We can create a future where hydrogen is pivotal in building a more sustainable transportation system. Toyota has invested significantly in hydrogen fuel cell technology for over 2 decades. They introduced the Mirai, the world's first mass-produced hydrogen fuel cell electric vehicle, in 2014, which has since undergone numerous updates and improvements. The company isn't solely focused on water-powered engines. It's also exploring hybrid and fuel cell technologies, demonstrating its commitment to sustainability. Toyota's new fuel cells. To broaden the use of fuel cells beyond cars, Toyota redesigned their technology into smaller modules. These modules integrate all the essential components for generating power from hydrogen, such as the fuel cell stack, air and hydrogen supply components, cooling systems, and power control, into one compact package. This package can be easily adapted for various products and situations. Toyota offers 2 module shapes, a box and a flat rectangle, to accommodate different setups. Each shape has 2 versions, providing either 60 kilowatts or 80 kilowatts of power output. This setup enables the utilization of hydrogen power in numerous new applications. Toyota's fuel cells employ proton exchange membrane technology, which converts the chemical energy released from the reaction of hydrogen and oxygen into electrical energy, emitting only water. Additionally, with a unique Toyota innovation, some of the water produced is directed to the membrane to keep it moist, eliminating the need for a separate humidifier in the fuel cell module. Since 1992, the company has continuously improved its fuel cells. Their second-generation fuel cell modules are assembled at TME's R&D Center in Brussels. Starting in January 2022, this facility will operate a pilot assembly line using advanced technologies for high-quality assembly. The decision to assemble in Europe aims to meet growing regional demand. TME's Fuel Cell Business Group collaborates with entrepreneurs interested in integrating Toyota's technology into their applications, offering necessary engineering support. Toyota's new fuel cell module has a broad voltage range from 400 to 750 volts and can easily connect to electrical devices. It includes a built-in fuel cell boost converter that simplifies the development and production of fuel cell products. The modular design enhances convenience, as the 4 available models can be combined to match different output levels and installation spaces. This modular approach eliminates the need for designing individual installations for each fuel cell system component, streamlining installation processes to ensure safety with hydrogen and high voltage. Various precautions have been implemented to prevent hydrogen leaks, and in the rare event of a leak, it is swiftly detected and stopped. The Toyota module is designed to function in diverse operating conditions, including extreme temperatures, high altitudes, and high vibration environments. Several companies have expressed interest in using Toyota's fuel cell modules. Toyota has supported experienced engineers in optimizing designs for fuel efficiency, longevity, and operating costs. This innovation has resulted in a world-class output density per unit volume. The maintenance requirements of Toyota's new module are simple and infrequent, reducing overall costs from procurement to disposal. Hybrid synergy drive. To drive in the future, cars must enhance their environmental and safety performance while remaining enjoyable. Traditionally, manufacturers would increase engine size or use supercharging to boost power and torque to make cars more thrilling to drive. However, this often resulted in lower fuel efficiency, creating a trade-off between power and environmental friendliness. Toyota introduced the Hybrid Synergy Drive, commonly known as THS, to change this dynamic in the Prius. This system breaks the trade-off between power and fuel efficiency, aiming to deliver strong performance and eco-friendliness. THS, a hybrid system, features a power split device that divides power into 2 routes. In one route, power from the gasoline engine goes directly to the wheels. In contrast, in the other route, a generator converts the engine's power into electricity to drive an electric motor or charge the battery. This unique setup enables features like engine stopping when idling, running solely on electric power, assisting the motor at any speed, and efficient energy regeneration. Importantly, this is achieved without needing a clutch or transmission. Thanks to a powerful motor with high torque and output at low speeds, the newly developed hybrid system, TS2, focuses on boosting power and enhancing the efficiency of transmitting motor power, improving overall vehicle energy management. This advancement led to the creation of the hybrid synergy drive, significantly enhancing power and acceleration while achieving top-notch environmental performance worldwide. THS2 builds upon the original THS to achieve even greater efficiency. The new system uses a high-voltage power circuit between the motor and generator, reducing energy loss during power transmission for optimal energy efficiency. TS2 relies more on the electric motor, shutting off the engine when it's less efficient and solely using electric power when the engine is most efficient. TS2 operates at optimal fuel efficiency and generates the right amount of electricity. It also improves energy regeneration during deceleration and braking, enhancing electricity efficiency. To achieve the world's highest fuel efficiency, this new technology aims to meet stringent environmental regulations, such as ATP-ZEV in California, ultra-low emissions level in Japan, and Euro 4 regulations in Europe. This ensures exceptionally clean emissions, setting a global standard for environmental performance. THS2 increases motor power by 1.5 times compared to its predecessor by raising the revolutions per minute of the engine, motor, and generator. It utilizes a high-voltage power circuit and a more potent battery to increase power, resulting in a combination of motor and engine power that offers firmer and smoother performance. So how does the THS2 system work? This system seamlessly coordinates the engine and motor, with the motor starting the vehicle and supporting regular driving for better fuel efficiency. During quick acceleration, the high-output motor and engine collaborate to provide optimal power, enhancing efficiency and performance. This marks a significant advancement in delivering a smooth and powerful driving experience. Toyota independently developed all the significant parts of THS2, redesigning the high-voltage power circuit, motor, generator, and battery from scratch to elevate the hybrid system to new levels. The system comprises two power sources: a high-efficiency gasoline engine utilizing the Atkinson cycle, renowned for its high expansion ratio, and a permanent magnet AC synchronous motor with 1.5 times more power output. Additionally, it includes a generator, a high-performance nickel-metal hydride battery, and a power control unit. The power control unit manages a high-voltage power circuit that boosts the system's voltage to 500 volts for the motor and generator. It includes an AC-DC inverter from the hybrid battery to switch between AC and DC currents. Another crucial component is the power split device, which allocates and merges mechanical forces from the engine, motor, and generator. To ensure efficient collaboration, the power control unit manages these parts at high speeds. The high-voltage power circuit is a significant innovation that enhances the THS2 system. With a newly developed circuit within the power control unit, the voltage supplied to the motor and generator has increased from 274 volts in THS to up to 500 volts in THS2. This advancement allows electrical power to reach the motor using a smaller current, improving efficiency. The motor in THS2 builds on Toyota's electric vehicle expertise, utilizing an AC synchronous type motor known for its high efficiency. It operates with AC and features neodymium magnets and a rotor of stacked electromagnetic steel plates for optimal performance. Additionally, arranging the permanent magnets in an optimal V-shape enhances drive torque and output. THS2 achieves 50 kilowatts from 33 kilowatts with the same motor size, making it the world leader in output per unit of weight and volume. THS2 introduces a new overmodulation control system for medium-speed range control to regulate the motor, complementing existing low and high-speed control methods. This enhancement improves output in the medium-speed range by up to 30% through refined pulse width modification methods. Similarly, the generator in THS2 is an AC synchronous type that provides sufficient power to the high-output motor. The generator spins at high speeds, increasing its output. Enhancements such as reinforcing the rotor have expanded the revolutions per minute range from 6,500 to 10,000, significantly boosting power delivery in the medium speed range and enhancing acceleration at low and medium speeds. Consequently, THS2 perfectly balances a potent motor and engine combination. What do you think about Toyota's new engine? Let us know your thoughts in the comments. Thanks for watching. See you in the next video.